We have the graph of a function in blue. We're supposed to graph its derivative, so we can symbolize that with f prime of x. That means the derivative of f of x. And a derivative is talking about all the instantaneous slopes of f of x. So the y-axis are slopes. It's no longer coordinates, okay? It's not 1 comma 2, okay? When you graph this at x equals 1, you need to be graphing the slope at x equals 1. And let's start there, actually. Here's x equals 1 on an original graph. If you're to graph the instantaneous slope, that means you want the slope of the tangent line. And if I was to try to draw a red line that touches just once, I'd get this horizontal line. That has a rise of 0 and a run of 1. That's a slope of 0. So that's my dot, my first dot for my derivative. Okay, let's keep moving to the right. Here, this is x equals 2. Somewhere between x equals 1 and x equals 2, I've got a slope that's negative. If I read that from left to right, it's going down. So between x equals 1 and x equals 2, I have a negative slope, and I can just make a guess at where that is. And then at x equals 2, I still have a negative slope. Maybe it's a little bit steeper, because if you look at the blue graph, it's decreasing, then it just kind of levels off and it's decreasing at the same rate. So negative 1, at 1.5, we got a negative slope. At 2, it's slightly more negative. At 3, it looks to be the same slope as at x equals 2. These tangent lines are now becoming approximately the same thing. So at x equals 2, x equals 3, they should be pretty close, unless we think it's decreasing. So there's my sketch of everything to the right of that. So let's get some more data points. We got, how about an x equals 0? So 0 in the original function. If I was to draw a tangent line, it's pretty weak. It's positive though. I'm increasing 1 to the right 2, it looks like. So at x equals 0, I have a slightly positive slope. I'll just guess that it's 1/2. I thought I lost the sneeze, but I caught it in the end. It's not very quick math of me, though, is it? So x equals 1. Negative 1, I should say. Here's x equals negative 1. If I was to draw a tangent slope, it's a little bit steeper than that last one. So it should be higher on the y-axis of my derivative. Look, this slope looks to be like 1/2. The slope at x equals 1, if I was to make a tangent line right there, that looks to be about 1. So at negative 1, I got a slope of positive 1. And then at x equals negative 2, it looks like it might even be a little bit steeper if I was to extend that line. So I'm going to guess at negative 2, we got an even more positive slope. Okay. And again, these are just guesses, these are estimations. Okay, you can't get it perfectly without knowing the function. So negative 2. So how about an x equals negative 3? Let's do that one. A lot of students when they first graphing these are like, okay, I got to start with dots here at negative 2, at negative 4, but that's not it, right? Because you're not graphing location anymore, you're graphing instantaneous slopes. So at x equals negative 3, look at what the slope is of that tangent line. It's horizontal again, so it's back down to 0. So somewhere between negative 3 and negative 2, we got to come back down to earth. These slopes are leveling off. They're getting smaller and smaller as we get closer and closer to negative 3. And then if we're moving this way, usually we do things left to right, but I started kind of near the center for some reason. At x equals negative 4, if I was to draw a tangent line, that looks like a pretty steep negative slope. My guess is like negative 4 or negative 3, something like that. So at x equals negative 4, I'm going to go down pretty far on the y-axis to make an estimation for my slope. And now how about something in between negative 4 and negative 3? If we make a tangent line on the graph there, it's negative. That's a decreasing slope, but it's not as steep as this other one that we just drew. So it should be a little bit above here. Maybe it's a slope of negative 2. So here's our rough sketch of the f of x that we were given.